Hi everyone, in this video I'm going to be working through a few must-know topics for your IGCSE Extended Mathematics Paper 2 exam. That's the paper without a calculator. Now of course, in one video we can't cover everything, so in this video I'm going to be showing you about the laws of exponents. That's what we'll be starting with here. We'll then move on to square roots, that is how to simplify a square root, how to rationalize the denominator. We'll be seeing a few examples of that. We'll then move on to covering a few of the things you have to know about coordinate geometry, such as finding the midpoint of 2 points, or the gradient of a line passing through 2 points, or a line equation, as well as the length of a line segment. We'll then do a quick recap on linear inequalities, and we'll finish this particular video, so that's video 1, on the highest common factor and least common multiple with powers of prime factors. All that being said, let's not waste any more time and let's get started. The first law of exponents that I want to make sure that you all remember is for any non-zero number, if we raise it to a power 0, then that will equal to 1. Now some examples of that could be, let's say you were asked to evaluate, let's say 0.7 raised to the power of 0. Then without even hesitating, you can simply state that's equal to 1. Or you could have 2.5 raised to the power of 0. Again, without hesitation, that's equal to 1. And let's give you one more example. Let's say we have pi raised to the power of 0. Well, again, that would be equal to 1. Okay, that's the first law I wanted to remind you of. The second law is when we multiply two powers of a same base. So some number a raised to the power of m times that same number a raised to a power n. Well, when that happens, we need to add the powers together. So that would be a raised to the power of m plus n. A quick example of that could be, let's say you're given an expression like this, 3x squared times y cubed times x raised to the power of 5. And you're asked, actually I'll tell you what, I'll even add a y squared here. And we're asked to simplify that as much as possible. Well, the trick here is to realize that inside this product, we can see that there are two powers of x and there are two powers of y. So we're going to be able to gather those terms, okay? Let me just sort of indicate that here with colors. And we can go ahead and say that's the same thing as 3 times x squared times x to the power of 5 times y cubed times y squared. Okay? And if I try and color coordinate this a bit, there are the two y's together, and here are the two x's together. All right, I carry on. I now use this law that I wrote over here, okay? And I use that for the x's and then for the y's. So that will turn into 3 times x raised to the power of 2 plus 5 times y raised to the power of 3 plus 2. Finally, that leads us to the answer 3 times x to the power of 7 times y raised to the power of 5. That's where we would stop. We can't simplify that any further. Okay, let me show you another important rule. Let's see, if we have a raised to the power of m over that same number a raised to a power n, then that will be equal to a raised to the power of m minus n. An example of that could be, let's say we're asked to simplify 2x raised to the power of 3 times y raised to the power of 5 over 4 times x to the power of, well, actually I'll just say x times y squared. Now the first thing I'll point out here is that when we write x on its own that way, what that actually means is that it's x raised to the power of 1. We simply never write powers of 1, but it is there. So with that in mind, what I now want you to focus on and realize is that what we're dealing with here is we have an x which is being divided by an x term, and we have a power of y which is also being divided by a power of y. And in fact, you could actually rewrite this to really make that clear. We could rewrite this as 2 over 4 times x cubed over x raised to the power of 1 times y to the power of 5 over y to the power of 2. Remember, in a multiplication, so when we're multiplying with fractions, you can split them up that way. It makes no difference. And I could even make a sort of generalized rule here, and I'll write it in the upper right-hand corner. If I have a over b times c over d, that's a multiplication there, well, that's the same thing as a times c over b times d. It's also equal to a times c over b times d. In other words, you can move things around in a multiplication with fractions. Okay, so writing it this way often makes it easier to visualize things. Now that all that's said and done, we can take care of each of these fractions in this product separately. So 2 over 4, well that simplifies, doesn't it? That's going to turn into 1 over 2, and that multiplies x cubed over x to the power of 1. Well, that's going to be equal to x to the power of 3 minus 1 times y to the power of 5 over y to the power of 2. And that turns into y to the power of 5 minus 2. Okay? Remember, all I'm doing here is using this third law that I've written. I try and tidy all that up as much as possible. That turns into 1 over 2 times x to the power of 2 times y to the power of 3. And as such, that's done. We could go one step further and say that's equal to x to the power of 2 times y to the power of 5, all of which is written over 2. Remember, thanks to the rule that I wrote at the top here, hopefully you can see now that whether we write this as our final answer or this, they should both be accepted. Okay, I'm carrying on. So this is kind of a power course on your laws of exponents here. But here's another quick and, dare I say, important result you need to know. The square root of a number a is the same thing as a raised to the power of 1 over 2. And that's quite a recurring thing in IGCSE exam questions, so make sure that you keep that in mind. We could actually, go one step further with that result and generalize it to say that, sorry, not 3, the nth root of a number a is equal to a raised to the power of 1 over n, okay? Remember, when we write the square root this way, we should in fact be writing it like this with a little 2 on top, okay? Which is where this result suddenly makes more sense with that proper notation. Now that's important because quite often in IGCSE exams, they'll throw things at us that look a little bit like this. Let me scribble something over here. Let's say we have in parentheses 4x raised to the power of 6 times y raised to the power of 8, and all of that's under a square root. Well, when you first see that, that may seem a little bit confusing, but in fact you need to realize that that can be rewritten as 4 times x to the power of 6 times y raised to the power of 8, and all that's raised to the power of a half. And that leads us to another important rule, and I'm starting to run out of space here, but I'll just write it here. If I have a number a raised to a power of m, and I raise that to a power n, then that's equal to a raised to the power of m times n. Another important rule that we need here is that if we have two numbers that are being multiplied inside a pair of parentheses, that's then being raised to a power, say power of n, then that power distributes onto each of the two terms inside that product. So that turns into a to the power of n times b to the power of n. Now, using all of that for this, we can therefore say that that's going to equal to 4 raised to the power of a half times x raised to the power of 6 times 1/2 times y to the power of 8 times 1/2. And hopefully you can see there. This will equal to 4 to the power of a half, which, remember, is the same thing as the square root. So that's the square root of 4, which is 2, times x raised to the power of 6 times a half, so that's 3, times y raised to the power of 8 times 1/2, well, that's equal to 4. And that's where we would stop. So you can see there's quite a lot going on there. Now I'll give you one last, dare I say, important result. And let's see, that would be a raised to the power of negative n. Now, in the case of exponents or powers of numbers, when we're dealing with a negative power, it means that we're dealing with a reciprocal. Or I want to say, I could almost make that simpler and say it means we're dealing with a fraction. So remember that a raised to the power of negative n means 1 over a raised to the power of n. Okay, so this a to the power of negative n means the reciprocal of a to the power of n, which is what we have here. Now, at IGCSE exams in paper 2, they quite like to use this, and I'll give you a quick example of where that could come in handy. Let's say you're asked to calculate or evaluate 8 raised to the power of negative 1/3. Okay, and sorry, that third is a bit big. That should be a power, so let me make that smaller. 1/3. There we go. Okay, well, the first thing to realize here is that because this is a negative power, what we're actually working with here is 1 over 8 to the power of 1/3. Okay, now I look at this 8 to the power of 1/3 and we go back to what we wrote up here. Okay, these sort of fractional exponents here. And the key thing to realize here is that if ever we're dealing with 8 to the power of 1/3, then technically we should be using this result. And instead of 1 over n here, it's going to be a 3 on the root. So it'd be 1 over 3, and that corresponds to the cube root. Okay, so going back to our fraction here, that means we're dealing with 1 over the cube root of 8. And the cube root of 8, well, that's 2, because 2 times 2 times 2, so 2 to the power of 3, is equal to 8. So that's just equal to 1/2. And there we go. That would be the first, and I'm not saying those are all the laws, but that would be a first good recap of the laws of exponents. Now, if you want, go ahead and press pause, make some notes, try and redo those exercises. In any case, now we're going to move on to the second section of this recap, which is on square roots. Now, when it comes to square roots, there are a few things you need to know. And the first of those things, is how to simplify a square root. Okay, now for the sake of time, I'm just going to show you this method for one square root, and then we'll get busy with some more examples. So let's say we're asked to simplify, the expression square root of 12 plus the square root of 75. Okay? Now, when they do this, they obviously want us to write this in its simplest form. And for that, the trick is, well, you're going to have to simplify each of these square roots on their own or individually, and then see if the whole thing simplifies. So let's do that. Remember that to simplify a square root, the idea is you're looking for the largest square factor of what's underneath the root. Now, square factors, if you're wondering what those are, let me just quickly remind you of how to find those. You know, we have our first few whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. And the square numbers are simply obtained by squaring each of these numbers. Again, I'll do that directly underneath those. So if we call those are the different numbers, then the corresponding squared numbers would be 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared, which is 49, 8 squared, which is 64, and so on and so forth. Okay, now with that in mind, the way we're going to simplify each of these square roots is to look for the largest number in this second row here, so the list of square numbers, which is a factor of whatever is under the square root symbol. So let's see. Let's focus on 12 for a second. The largest factor of 12 we can see in this list, well, hopefully you'll agree with me, but the largest factor is 4. Indeed, you know, we can quickly see, in fact, we can make a note already, we can quickly see that that's the same thing as the square root of 4 times 3, right? That's our 12. Okay, and I'm getting the 4 just for the sake of color coordinating. That 4 was found from this list of numbers here. I now need to do the same thing for this square root of 75 here. And so I look for the largest factor of 75 I can find inside this list of numbers. And hopefully you'll agree that the largest factor of 75 we can see here is 25. So I can go ahead and rewrite that second square root as 25 times 3. Okay, now that that's done, we're going to be using an important law when it comes to square roots. And I'll write it over here, and that is that the square root of a times b is equal to the square root of a times the square root of b. And it's worth noting that this result should be read from left to right, but also from right to left. Indeed, at times, reading it from left to right or right to left, depending upon the circumstances, one or the other will be needed. Here, though, we're going to be using this result to split each of these two square roots into smaller products. And here's what I mean. This first one can now be rewritten as the square root of 4 times the square root of 3. And the second one can then be written the square root of 25 times the square root of 3. Now, here's the whole idea. Since 4 and 25 are square numbers, they're going to come out of these square roots very nicely. Indeed, the square root of 4, well, let's see on our list here, square root of 4 would just be 2. So that turns into 2 times the square root of 3. Plus the square root of 25, well, the square root of 25 is just 5. So that's plus 5 times square root of 3. And so now we see that we have 2 root 3 plus 5 root 3. And since in both cases here we have a square root of 3, we can gather those terms and say that that's equal to 7 root 3. And that's that expression simplified. The next thing we really need to know how to do for IGCSE exams is to rationalize the denominator. And I'll just write it like this, rationalize the denominator. Okay, rationalize the denominator. Okay, now, the simplest of these scenarios are to rationalize something looking like this, 3 over the square root of 2. Now, the whole idea behind rationalizing the denominator is to get rid of any square root we have on the denominator. In other words, in our final expression, there mustn't be a square root on the denominator. And so for fractions like this one, the trick is to say that this is equal to 3 times the square root of 2, so nothing special so far, times the square root of 2 over the square root of 2. Now, we're allowed to do this because square root of 2 over square root of 2 is equal to 1. So we're not changing this fraction's value by multiplying it by 1. But we are going to change how it looks. When you multiply two fractions, the numerators multiply together. So at the top here, we'll have 3 root 2. And on the denominator, we have the square root of 2 times the square root of 2. But the square root of 2 times the square root of 2, well, that's just equal to 2. So we end up with 3 root 2 over 2. And that's the simplest scenario dealt with. The second scenario, though, and in fact, I'll put a little 1 there, and now we'll do a little 2. There we go. The second scenario that you need to know how to deal with is the following. Let's say we have 3 over 4 minus the square root of 2. Well, in this case, this is a bit trickier, okay? But the idea, though, is as follows. We can state that's equal to 3 over 4 minus the square root of 2 times, and pay attention to the fact that it's 4 minus the square root of 2 here, times 4 plus the square root of 2 over 4 plus the square root of 2. Again, I'm allowed to do this. This second fraction here will just equal to 1, so we're not changing anything here. We're just going to change how things look. Multiplying those two fractions together, though, we then end up with 3 times, in parentheses, 4 plus the square root of 2 on the numerator, and on the denominator we have 4 minus the square root of 2 times 4 plus the square root of 2, okay? And here's how things work out nicely. You should remember the important result that we've seen quite a few times now, and that is the difference of two squares. And I'll try and write it on the far right-hand side here. Remember, actually, no, I'll tell you what, I'll write it up here because it's so important. You really want to have this in the back of your minds. Here, if you have a minus b times a plus b, well, that will always equal to a squared minus b squared, okay? And I could have written a plus b times a minus b, by the way. The order there doesn't matter. But with this result, we're going to be able to take care of this denominator. Indeed, this is the same thing as a minus b times a plus b. So distributing these, we'll just end up with a squared minus b squared. So that's going to be 4 squared minus the square root of 2 squared. And in fact, let me detail that for this one. That's going to equal to, well, let's see, on the numerator, we'll distribute the 3 across that pair of parentheses. So that's 3 times 4, which is 12, plus 3 root 2. Okay, the numerator is taken care of. We can't simplify that any further. But as I said a few seconds ago, this 4 minus root 2 times 4 plus root 2 should be thought of as a minus b times a plus b. Yeah? So that's going to equal to the equivalent of a squared minus b squared. So in this case, that will be 4 squared minus the square root of 2 squared. And if I go ahead and write that, that's 4 squared minus the square root of 2 squared. And I'm a bit uncomfortable writing it that way, so I'll put it in parentheses. There we go. Now, 4 squared is 16. Okay, so that's going to become 16. And the square root of 2 squared, well, that's just equal to 2. So we end up with 12 plus 3 root 2 on the numerator over 16 minus 2. We simplify one step further. That's 12 plus 3 root 2 over 14. And that's the answer. There's one third and final step or scenario that I can think of on the spot this way. And again, I'm not saying that this is exhaustive in the sense that maybe in an exam they'll come up with something different for you. But this should still be pretty good guidance or something good to refer to. Another type of rationalization of the denominator could be something like this. You could be asked to rationalize, let's see, 5 minus the square root of 3 over 5 plus the square root of 3. Now this, I've seen these in the past in past papers. These can be a bit nasty, really, but there's things still work out nicely, and you'll quickly see why. Let me just draw a line of separation here. There we go. The trick here is to rationalize the denominator in exactly the same way as we did up here. Okay, so I'll go ahead and say that's equal to 5 minus the square root of 3 over 5 plus the square root of 3 times, and this time because it's a plus, we're going to say times 5 minus the square root of 3 over 5 minus the square root of 3. Okay, that's a 3 there. Okay, now with that in mind, I now multiply the numerators together, and in doing so, hopefully you can see right away that we're faced with 5 minus root 3 times 5 minus root 3. Okay, so that's going to be 5 minus root 3 squared. And all of that's written over 5 plus root 3 times 5 minus root 3. Okay? Now here's the trick. On the denominator here, and sorry, that should be 5 plus root 3, shouldn't it? Ooh, thank goodness for that. Okay, 5 plus root 3. Now, on this denominator here, we've got the same scenario as we did up here, right? That's our a plus b times a minus b. So we're going to take care of the denominator using this result here, a squared minus b squared. Great. On the numerator, though, we have this 5 minus root 3 squared. And for that, you are expected to remember this result. Remember that a minus b squared is equal to a squared minus 2ab plus b squared. And while I'm at it, I'll write the other result. You're meant to know a plus b squared, which is equal to a squared plus 2ab plus b squared. Remember those, please. So using that, in particular the second one we have here, for this numerator, and comparing 5 to a and square root of 3 to b, this will turn into, and let me move the equal sign further to the left here. Okay, so just to be clear, moving that all the way over there. That will turn into 5 squared minus 2 times 5 times root 3 plus the square root of 3 squared. And all of that's going to be written over, well, let's see, it's going to be 5 squared minus the square root of 3 squared, right? Because there I'm using the same result as we did earlier on. And so that's going to be 5 squared minus the square root of 3 squared. Okay, now it's just a matter of tidying all of this up. That's going to equal to 25 minus 10 root 3 plus the square root of 3 squared, which is just 3. And that's written over 5 squared, which is 25, minus the square root of 3, which is 3. We're nearly there. 25 plus 3 is 28. So on the numerator, we'll have 28 minus 10 root 3, and we can't go any further there. And that's written over 25 minus 3, which is 22. And in fact, we're not quite done, and the reason for that is because there's a common factor for all of the terms we see here. Indeed, 28, 10, and 22 have a common factor of 2, so to simplify this as much as possible, we should in fact be writing 14 minus 5 root 3 over 11. And that's the answer. Okay, that's it for simplifying square roots, rationalizing the denominator, and we've shown that for 3 different cases here. So hopefully that helps a bit. We move on to the next topic. Now in this case, we're looking at coordinate geometry, right? And as the name suggests, what we're going to be dealing with here are points and their coordinates. And so what I'll do is I'll give you 2 points. I'll say that we have a point A with coordinates -2, 8, and a point B with coordinates 4, -4. Okay? And let's see. The first thing that we need to know how to do, really, the first thing is, I'll just put a little a, you need to know how to find the midpoint, right? The midpoint of the line segment AB, okay? Now, for that midpoint, which will be original and call capital M, well, let's see. How will we do that? Let me try and remind you of the formula in the upper right-hand corner here. If I have a point with coordinates, I'll say, let's say I've got one point P with coordinates x1, y1, and another point Q with coordinates x2, y2, then the midpoint, I'll say capital M, will have coordinates x1 plus x2 over 2, y1 plus y2 over 2. So hopefully you can see that what's actually happening here is that the midpoint of 2 points has x-coordinate, which is the average of the 2 x-coordinates of the endpoints. And same can be said for its y-coordinate. The y-coordinate of the midpoint is the average of the endpoints of that segment, okay? So using that here, we can say that the midpoint M will have coordinates, well, let's see, that's x1 plus x2 over 2, right? So it's the average of -2 and 4. And so if I could quickly do that, -2 plus 4 over 2. And its y-coordinate should be the average of 8 and -4. So that's 8 plus -4 over 2. We carry on. That quickly turns into capital M equals to -2 plus 4, which is 2 over 2. And 8 plus -4, this 8 plus -4 here means 8 minus 4. So that turns into 8 minus 4, which is 4, and that's 4 over 2. Finally, we quickly see that the midpoint, capital M, will have coordinates 1, 2. Done. Okay, that's the first thing there. So make sure that you're comfortable finding the midpoint. Next thing, quite important, you need to know how to find the gradient of the line passing through points A and B. Okay, gradient, and it's often just phrased as gradient of AB. They could say gradient of the line passing through the points. They could even say gradient of the line segment. They could also use the word slope instead of gradient, right? But in theory, you know that the word gradient is the same thing as the word slope. So for that, the formula that you need to know, and hopefully you remember it, it's a lowercase m for the gradient. Okay, so these two m's are not the same. And the gradient has formula y2 minus y1 over x2 minus x1. Okay, and I should say it doesn't matter which of the points you have. Here we're working with A and B. It doesn't matter which one we say is x1, y1, and x2, y2. It really doesn't matter. What matters is that you're consistent with it. Okay, so meaning looking at this formula here, it matters that the x2 and y2 that we see first on both the denominator and the numerator, they both come from the same point. And we're taking away the x and y coordinates of the second point, okay? So with that formula, we can say that the gradient of m of AB, well, let's see, if we go ahead and say, I'll say that A is x1, y1, and that B is x2, y2, okay? I'd remind myself of the formula in my exam, right? So I'd actually go ahead and write that. And then I'd say, okay, well, therefore, that's y2 minus y1, so that's negative 4 minus 8. Let me just write that. That's negative 4 minus 8 over x2 minus x1. So that's going to be 4 minus negative 2. All right, so let's write that, 4 minus negative 2. Now, negative 4 minus 8 is negative 12, and 4 minus negative 2, well, that turns into 4 plus 2, so that's 6. You don't stop there. This needs to be simplified. Negative 12 divided by 6 is equal to negative 2. So m would be equal to negative 2. Okay, that would be the gradient of that line. Do make sure you memorize that formula, people. It's an important one. Okay. Another thing I've also seen in past papers, at times, now I'll really just bounce off the result we just had, actually. We could have been asked to find the line equation find the equation of the line passing through these same 2 points, A and B. Okay, and they could actually say, write it in the form y equals to mx plus c. Okay, now if that's the case, to do that, the first thing you need to find here, is this line's gradient. So that's m. And that's what we just found down here, right? That's the negative 2, since we're dealing with the same 2 points. So I'll just say find m. Okay, and for m, of course, we're not going to redo the working. It would be identical to what we just did there. Okay, so m would be equal to negative 2. Once that's done, you find c. Okay, find c. Now c, to do that, you are going to use either of the 2 points you started off with. So negative 2, 8, or 4, negative 4. Doesn't matter which one you take. Doesn't matter which one you choose. Just choose whichever one seems to be easier to work with to you. So I'll go ahead and use, I don't know, I'll use a. Using a with coordinates negative 2, 8. What I'm going to do is I use the fact that I know that the line equation has to look like this, y equals to mx plus c, alongside the fact that I know that the gradient m is negative 2. Okay, so I'm going to use that point A with the line as it currently stands as y equals to negative 2x plus c. Okay, so I'm doing that since I know that the gradient m is negative 2. Okay, but now since this line has to pass through this point A, well, that tells us that if we replace x by negative 2, then the y value we get should be equal to 8. And so writing that, in other words, replacing x by negative 2 and y by 8, that's going to lead to a method, or I should say lead to an equation for this c. So let's go ahead and do that. That will be 8 equals to negative 2 times negative 2 plus c. That's 8 equals to negative 2 times negative 2, which is 4 plus c. And subtracting 4 from both sides, we quickly find 4 equals to c. In other words, c equals to 4. And so combining the fact that m equals to negative 2 with the fact that c equals to 4, we can state this line's equation as y equals to negative 2x plus 4. And that would be the answer there. Okay, good. Let me think. Probably the last thing that's coming to mind, at least right now, is the fact that you need to know how to find the length of the line segment AB. And that could also be called the distance between those 2 points. Okay, and the formula for that, we've seen that before. Basically, it's Pythagoras' theorem in disguise. But if I call the length of the line segment capital L, then it's equal to the square root of, in parentheses, x2 minus x1 squared plus y2 minus y1 squared. Okay, that's the formula we had seen. So just to be clear, this x2 and x1, they're still just the coordinates of the points, right? Same for y2 and y1. They're the coordinates of our 2 points. So for this particular line segment, AB, we can go ahead and say that the length AB is equal to, so in parentheses, don't worry, I'll write the square root at the end. So x2 minus x1, so that's going to be 4 minus negative 2. Let me just quickly write that. That's 4 minus negative 2 squared plus y2 minus y1, so that's going to be negative 4 minus 8. So that's negative 4 minus 8 in parentheses squared. All of that's under a square root. That's equal to, now we've got to tidy all of this up. Let's see, 4 minus negative 2. Well, that's just going to be, I'll detail it. That's 4 plus 2 squared plus negative 4 minus 8. That's negative 12 squared. Okay, and all of that's under a square root. That will quickly turn into, well, 4 plus 2 is, of course, 6. So that's 6 squared. And the second one, we have negative 12 squared. And you can go ahead and check with your calculator and make sure that's in parentheses, by the way. And in fact, I'll tell you what, I'll even put that 6 in parentheses as well, just for the sake of being consistent. Negative 12 squared. There we go. That's still underneath the square root. Finally, I take care of the squares. So 6, you could actually plug all of that in your calculator if this were a paper 4. But because I said this is paper 2, let's carry on by hand. 6 squared would be 36 plus negative 12 in parentheses squared means negative 12 times negative 12, which is positive 144. That's still under a square root. Finally, 36 plus 144, well, you can go ahead and check, but that should be 180. So we're dealing with the square root of 180. And technically we're done here, although maybe some of you can see that you can actually simplify that square root. Indeed, and to save time, I'll just show you the result right away. But the largest square number, which is a factor of 180, will be 36. So that's 36 times 5, okay? That's equal to 180. And, if you're wondering how I get that quickly, well, I simply know that 180 is half of 360. That's the number that comes to mind there. And so if 180 is a half of 360, well, since 360 is 36 times 10, 180 will be 36 times 5. And 36 is a square number, of course. So I can now say that's equal to the square root of 36 times the square root of 5, which is equal to 6 times root 5. Truth be told, though, to be perfectly honest, I believe that you'd be okay with that. In any case, you definitely get the vast majority of the points for writing that. Okay, so don't let that particular example of simplification there worry you too much. But do try and make sure you know how to do it nonetheless. That being said, that's a good review or summary of some of the things you need to know for coordinate geometry. Let me move on to the next topic. Here, inequalities. Now, this is going to be short, really. Inequalities, I just felt that it would be nice to remind you of a couple of things. Let's say you're asked to solve 2x plus 1 less than 4x minus 7. Okay, and here I said less than. Okay, I could have written greater than. I could have said less than or equal to. All the inequalities work in the same way. Okay, here we have 2x plus 1 less than 4x minus 7, and we need to solve this. You're going to solve this technically, in the same way as you would solve the equation 2x plus 1 equals to 4x minus 7. Okay, the steps are identical. There's simply one very important rule to remember that distinguishes inequalities from equations, okay? And that is if ever you multiply or divide both sides of an inequality by something negative, then you swap or you reverse the inequality symbol. What I mean by that is, here it says less than. If I were to multiply both sides by, say, negative 1, then this would turn into greater than. Okay, so remember, if you multiply or divide both sides of an inequality by something negative, then you flip the inequality symbol. That aside, though, or I should say aside from that, you're going to solve it following the same steps as you would follow for this equation. So let's go ahead. The first thing I'll do here to solve this is I'm going to get rid of, I'll gather all the x's on the left-hand side. You could gather them on the right-hand side, by the way, it doesn't matter. But I'll gather all the x's on the left-hand side. And I'll do that by, first I'll get rid of the 1 that's being added to the left-hand side. And so I do that by subtracting 1 from both sides. Right, so that's going to be 2x less than 4x minus 7 minus 1, so that turns into minus 8. Okay. The next thing I'll do here, well, like I said, I want to gather the x's on the left-hand side. So I'll get rid of this positive 4x on the right-hand side, which I do by subtracting 4x from both sides, okay? So now on the left-hand side, I'll have 2x minus 4x, so that's negative 2x, which is less than 4x minus 4x. Well, 4x minus 4x is 0, minus 8, so that's just negative 8. Finally, I need to get rid of this negative 2, which is multiplying the x, and to do that, I'm going to divide both sides by negative 2. But be careful, as I said at the beginning, when we divide both sides, or when we multiply both sides by something negative, the inequality symbol swaps or reverses or changes. So here, because I'm about to divide by something negative, I change the inequality symbol to greater than. And so on the left-hand side, I'll have negative 2x divided by negative 2. So that just turns into x. And that's going to be greater than, remember I swapped the inequality, negative 8 divided by negative 2, which will be 4. And that would be the answer here, okay? Let me think, I'll give you one more example, maybe just to show you that you don't always have to swap the inequality. And let's say I had something like this, so I'll put a little 2 here. Let's say we have 5x plus 1 greater than or equal to x over 2 minus 3. Okay? Now again, we're going to solve this the same way. I'll choose to gather all the x's on the left-hand side, and so to do that, I'll start by getting rid of the 1 that's being added to the left-hand side. And I do that by subtracting 1 from both sides, of course. Okay, so that turns into 5x greater than or equal to x over 2 minus 3 minus 1. So that becomes minus 4. All right. Remember, I said I'd gather the x's on the left-hand side, but before I actually move the x around, let me just get rid of this fraction here. You know, I don't like working with a fraction like that, and you probably don't either. And so to do that, what I'll do is I'll multiply everything I see by this 2 that I see on the denominator. Okay? So by multiplying every single term by 2, we'll get rid of that fraction, basically, and we'll just be left with something much nicer. So let me just write that on the side here. I'll say I'll multiply the left-hand side by 2, and I multiply the entire right-hand side by 2 as well. So doing that on the left-hand side turns into 10x. That's greater than or equal to x over 2 times 2, so that turns into x, minus 4 times 2, which is 8. See, already it's looking much nicer. Next thing I'll do, of course, is get rid of the x on the right-hand side, and this should be thought of as a positive x. There's no minus in front of it. And so I'll do that by subtracting x from both sides. Okay. The left-hand side, I therefore have 10x minus x, which is 9x. That's greater than or equal to x minus x, which is 0, minus 8, so that's negative 8. Finally, I'm going to get rid of this 9 that's multiplying the x on the left-hand side, and I do that, by dividing both sides of this inequality by 9. And so we'll end up with x greater than or equal to negative 8 over 9. And you leave the final answer in that form. Don't do anything with that fraction. Done. Okay, good. So that's a quick recap of inequalities. Another one that you definitely want to make sure you know for your paper 2, and that is how to work with highest common factors and least common multiples, often just called HCF and LCM. Now, there are several approaches here. It's very important to know how to do this, and I should be more specific really, with prime factors, okay? And so let me just quickly remind you of how to write, I should say, I'm having trouble finding my words, how to write a number as a product of its prime factors. So let's see, I will choose, I'll just say, I'll give a little title, I guess, and I'll say this. I'll say, first of all, prime factorization. I'm writing that with a Z, you could write it with an S, it doesn't matter. So let's see, if I were to take the number, well, we'll start with something 36, okay? The whole idea behind prime factorization is to write 36 as a product of its prime factors, okay? Now, we're not going to dwell on this, but every single number out there every single whole number out there, I should say, can be written as a product of prime factors. And that stems from the fundamental theorem of arithmetic, which we don't have to worry about too much, but just know that it's always true, okay? To do that, it's important that you know your prime numbers. In fact, I would encourage you to list out the first few prime numbers a couple of times to make sure you get a sort of sense for them. So the first few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and we could go on, okay? Remember, prime numbers are numbers which only have two factors, themselves and 1, okay? So looking at 36, the whole idea is we're going to look for the smallest prime number, which is a factor of 36, all right? And to do that, I mean, hopefully you can see right away that since 36 is an even number, well, 2 has to be a factor, okay? And so here's how we actually present it. We'll write 36 in a table like this. We're going to split it with a vertical line. The smallest prime factor I can divide 36 by, or the smallest prime factor, which is a factor of 36, is 2. So I write a 2 right next to the 36 in that column. And now I do 36 divided by 2, which is 18. Okay? And now I repeat that process for 18. The smallest prime factor, or smallest prime number that 18 is divisible by, again, it's 2. So I write 2 again here. And 18 divided by 2, well, that's 9. So I write the 9 in the next row. Now, the smallest prime number I can divide 9 by is 3. So I write 3 right here. And 9 divided by 3, well, that's 3. So I write 3 underneath. Finally, the smallest prime number that is a factor of 3 is itself 3. So I write the 3 here. And 3 divided by 3 is equal to 1. And when you reach 1, you stop. What we've just shown here is that 36 written as a product of its prime factors is 2 times 2 times 3 times 3. In other words, 36 is equal to 2 times 2 times 3 times 3. And we tend to write that as 2 squared times 3 squared, okay? Done. That's how you write a number as a product of its prime factors. Let me give you one more example, just for the sake of showing you, I guess a couple of different examples. And let's say I have, I'll take 540. Let's go 540. Well, again, I put that in table form, so I put the 540 right there. And I look for the smallest factor of 540 that I can see inside this list. Again, I'm sure you'll agree, the first one would be 2. 540 divided by 2 will be 270. And 270 is still an even number, so I can divide that by 2. And that will be equal to 135. Now, 135... you're looking for the smallest prime factor. 5 is definitely a prime factor, by the way, so you could definitely divide it by 5. Or you could also notice that you can divide it by 3. The way I know that, of course, is if I add the digits of this number together, so 1 plus 3 plus 5, it's equal to 9. And because that's a multiple of 3, this number will be divisible by 3. So I'll go ahead and divide 135 by 3, and you can check, but 135 divided by 3 is 45. 45 is also divisible by 3. Again, that's still within our list of prime numbers, so we're okay. And 45 divided by 3 is 15. And 15 is still divisible by 3. So I can write another 3 here, and that gives us 5. And finally, 5 has a factor inside this list, and it's itself. So I write the 5 here and the 1 underneath, and that's where I stop. So 540 is equal to 2 times 2, which is 2 squared, times 3 times 3 times 3, so that's 3 cubed, times 5. And so we could write that as 2 squared times 3 cubed times 5. And you could write 5 to the power of 1 if that makes you more comfortable. Good. Okay, so now that we know how to, or now that we've been reminded of how to write a number as a product of its prime factors, let's quickly see how to find the highest common factor and the least common multiple of two numbers using this method, okay? And so I'll go ahead and I'll make a little line of separation here, and I'll say, let's just do both HCF and LCM of, and I'll say 144 and 180, okay? Now, the first thing we need to do here is to write each of these two numbers as a product of prime factors. Okay, and so I'll quickly do that here. 144, you may want to press pause and check that you can still do it with these numbers, and quickly check after that. So 144 divided by, written as a product of its prime factors. So remember, I'm using the list of numbers up here. And I'll go fast this time. So 144 can be divided by 2. That gives me 72, which I can divide by 2. 36 divided by 2 gives us 18. Divided by 2 gives us 9, which I can divide by 3 gives us 3. Divide by 3 again, that gives us 1, and we stop. So here we can see that 144 is equal to 2 times 2 times 2 times 2 times 3 times 3. So I'll quickly write that. 144, is equal to 2 raised to the power of 4 times 3 squared. I do the same for 180, okay? So let's try and go fast again. Again, don't hesitate to press pause first to see if you can do it, and then I'll just do it very quickly here. So I can divide 180 by 2, which gives me 90, which I can divide by 2 again, which gives me 45, which I can divide by 3, 15. I can divide that by 3, which gives me 5, and I can divide 5 by 1. Sorry, 5 by 5, which gives me 1, I meant to say. Right, so 180 is equal to 2 squared times 3 squared times 5. Okay? Now, how do we actually find the highest common factor? We'll start with that. Okay, and I'll sort of try and color coordinate this a bit. So I'll do the highest common factor, and I'll underline that method in orange. And the least common multiple will be, say, we'll use blue for the least common multiple. Okay? So here's the idea. The highest common factor, HCF, you're looking for all the prime factors that these two numbers both have, so that they have in common. Now, both of these numbers have the prime factors 2 and 3, right? They don't both have 5, though, but they do both have 2 and 3. So before I even speak of writing the powers here, I'm only going to write what they have in common. Now, for the highest common factor, you now look for the smallest or lowest power of each of these factors you can see. So the smallest power of 2 that I see here is 2 to the power of 2. So that's what will go inside the HCF, okay? The smallest power of 3 that I see, well, let's see. Well, actually, they both have the same power of 3, so there's no doubt here. It's 2 as well. And that's the highest common factor, okay? Done. So I'll just put a little note here. Smallest power of each prime factor they have in common. Okay, sorry, my writing's a bit scruffy. I'm trying to go fast. And now for the least common multiple, LCM, well, let's see. For the least common multiple, here, on the other hand, it doesn't matter whether both numbers have the factor or not. You're going to start by writing every single factor that you actually see. So we see a 2 and a 3 in the first one, and we see a 2 and a 3 and a 5 in the second one. So no matter what, I can tell you right away that the least common multiple will be some product involving 2, 3, and 5. Okay? Now, for the powers that go on each of these factors, for the least common multiple, you look for the largest power you see, or the highest power you see. So for the power of 2 here, well, that's going to be 4, right? That's the largest power of 2 that we have. So it's going to be equal to 2 to the power of 4 times 3. Well, again, both of these numbers have the same power of 3, which is 2. So that's going to be 3 to the power of 2. And the largest power of 5, well, that's the 5 we have here. Again, we don't write it, but, technically that's 5 to the power of 1. Okay? And that's it. That's the least common multiple of those two numbers. Now, in a paper 2, you're more than often, they'll ask you to leave it in this format, right? Written as a product of powers of prime numbers. Okay, you're not expected to go ahead and calculate this, so don't worry. But you are expected to now to write that. Remember, there's a multiplication in between these, okay, in your final result, so make sure that that's written as well. And there we go. Okay, hopefully that's helpful. All right, everyone. So those are the first things I wanted to quickly remind everyone of for their paper 2 IGCSE, and hopefully those few tricks or tips, I should say, are helpful. That being said, that's it for this tutorial.